Section 4.1, Systems of Linear Equations in Two Variables. So we are moving on to Chapter 4, and we will be solving systems of linear equations in this chapter. So we are going to start off very basic. We're going to start with two equations and two variables, okay? So something that looks like this, okay? So let's go ahead and read this first statement. It tells you what a system of two linear equations and two variables means, okay? A system of two linear equations and two variables has the form this. So two equations, the first one is a times x plus b times y equals h. And then the second one is c times x plus d times y equals k. Okay, so what's going on here, first you need to notice you have two equations. Okay, here's the first one, here's the second one. Okay, there are two variables involved in each one. Okay, so x and y are variables, they are unknown. And then the rest of the letters you see represent numbers. Okay, so A, B, C, D, H, and K are constants or just numbers. Okay. So again, we have two equations. There's two variables, x and y are involved in both of the equations. Okay, there are no other variables. And then you hear or you see this word linear, okay? So what this means, linear, okay, linear equation, the highest, well, I should say not the highest, I should just say the power or the exponent, let me rewrite that. So the power of or the exponent on each variable is 1, okay? That's what linear means, okay? You're going to see x, you're going to see y. You won't see x squared or x cubed or x to the fourth and so on. You won't see y squared, or sorry, yeah, you won't see y squared or y cubed or y to the fourth and so on, okay? So the power of or the exponent on each variable is 1. That's what makes it linear, okay? So that is what a system of two linear equations in two variables looks like, okay? When we talk about the word system, we are considering both equations at the same time, okay? We're not looking at them separately. We are considering them simultaneously, okay? All right, so like I said, we are going to be interested in solving systems of equations. We are starting off small with a system of two linear equations and two variables. Eventually, as we progress through the chapter, we will look at larger systems, more equations, more variables, and starting off small will help us learn techniques that can be applied to solve bigger systems. Okay. All right. So in the second bullet point, it talks about what a solution to a system of equations is. Okay. A solution of such a system is an assignment of values for the variables that makes each equation in the system true. Okay, so you are trying to find, like if you were, it'll make more sense when we actually do this, but if you're trying to solve something like this, you are looking for the x value and the y value that make both equations true at the same time. Okay, so you're looking for the x and the y that you would plug into each equation. Okay, it has to be the same x and the same y. Okay, you plug into each equation, it would make both equations true. Okay, all right, so that's what that means. Okay, to solve a system means to find all the solutions of the system. The set of all solutions is called the solution set. Okay, we will talk about this as we progress, but it is possible for a system of equations to have more than one solution. So anytime you're solving your system, you have to find every single solution that works. Okay, if a system has more than one solution, it's not good enough to find just one solution. You have to find all the solutions. So that's what we mean by solving the system, finding all the solutions, and all the solutions comprise the solution set. Okay, so there's some terminology going on here that you will hear throughout this chapter. Okay, all right, so let's take a look at example 1. Example 1 asks, is each of the following systems of equations a system of two linear equations in two variables? If a system is a system of two linear equations in two variables, decide whether the given variable assignments are solutions of the system. Okay, so we have 3 different systems of equations here, okay? And we are going to run through A, B, and C here to determine whether or not each system is a system of two linear equations in two variables, okay? And then if it is, we will talk about, I'll give you some potential solutions, and we'll look at each one and decide whether or not the assignment given is a solution or not. Okay, let's take a look at example A. Our 2 equations are 3x plus 2y squared is equal to 30, and the second one is x minus y is equal to -5. Okay, well, we have 2 equations. There are 2 variables. I only see x and y, no other variables. The problem with this one is that it is not linear, okay? I see right here when I look at this term, okay, I see a y squared in there, okay? And remember, linear means you're only going to see x and y. You won't see any powers of x or y other than the first power, okay? So this is, we're just going to write no, okay? This is not a system of two linear equations in two variables, okay? Because this system is not linear because of that first equation, okay? So something like this, you would not have to solve, okay? All right, let's look at part B. Okay, the system is now 5x plus 2y equals 30. The second is 2x plus y equals 10. Okay, we have 2 equations. Each one involves 2 variables, okay, and they involve the same 2 variables, x and y, okay, and both of the x's are raised to the first power, and both of the y's are raised to the first power, okay. Remember, when you see 2y, this is 2 times y to the first power. 2 is just the number that y is being multiplied by. Y itself is raised to the first power, okay. So this does constitute a system of 2 linear equations in 2 variables, okay? So after we look at part C, we will come back to this one, and I will give you some potential solutions to look at, okay? So let's jump really quickly to part C, okay? Again, is this a system of 2 linear equations in 2 variables? Okay, our first equation is -6x plus y is equal to 17, and then our second equation is 2x minus z is equal to 5, okay? You have 2 equations, okay? There are actually 3 variables, so that's the problem here, okay? There's an x, a y, and a z involved in the system, okay? So since there are 3 variables involved, this is actually a system of 2 linear equations in 3 variables, okay? It is a linear system because x is raised to the first power everywhere, so is y, so is z. But the problem here is having that third variable, okay? So this does not meet the requirements of what we're looking at right now. So we're going to put a big no. It is not a system of 2 linear equations in 2 variables, okay? All right, let's go back to part B because we said this is a system of 2 linear equations in 2 variables. I am going to give you 2 variable assignments, okay? A value for x and a value for y, and we're going to say, you know, is that part of the solution set for this particular system, okay? All right, so I'm going to go up here and I'm going to say, okay, so variable assignment number 1. Okay, we're going to say x equals, I don't know, let me make something up, -4, y equals +25, okay? Is that a solution to the system in part B? Okay, and here I'll draw a line so that we know we're only talking about part B. Okay, so what you need to do to check, okay, you need to plug in x equals -4 and y equals 25 into both of these equations, okay? If it's a solution, it should make both equations true, okay? So if we plug into the first equation, so I'll go ahead and write it, 5x plus 2y equals 30. Let's look at that one first, okay? So I'm going to do 5 times x is negative 4, plus 2 times y, which is 25. Is that 30? Okay, so let's see. We're going to get negative 20 plus 50 equals 30. So we get 30 equals 30. So we get a true statement. Okay, we plugged in this variable assignment and into the first equation there, and we got a true statement. Okay, you cannot automatically conclude that this is a solution to the system. You need to check the second equation as well. It's got to work in both. Okay, maybe it works for the first and not for the second. Okay, so let's move on and check 2x plus y equals 10. Okay, so again, plug in negative 4 for x, 25 for y. So we're going to get 2 times negative 4 plus y is 25. Is that equal to 10? That's what we're checking. Okay, so if we simplify, we're going to get negative 8 plus 25 is equal to 10. Okay, so if we simplify the left side, negative 8 plus 25 is 17 is equal to 10. That's not true. Okay, so this first variable assignment is not a solution to our system of equations, because if you plug it into the first equation, it works, but if you plug it into the second equation, it does not work. Okay, so we're going to say this is not a solution to the system in part B. Okay, all right, let's look at a second variable assignment. Okay, so let's see here, where can I write? All right, so again, we're only looking at example B because it was the only one of the three that was a system of two linear equations and two variables. Okay, so for this one, we're going to go ahead and say variable assignment number 2. Let's see, let's check x equals positive 10 and then y equals negative 10. Okay, so this is going to be our variable assignment. Okay, again, we have to plug these values of the variables into each equation. Okay, so back to the first equation, 5x plus 2y is equal to 30. Okay, let's plug in there first. Okay, so I'm going to substitute 10 for x and negative 10 for y. So I'm going to get 5 times positive 10 plus 2 times negative 10. We're trying to see if that gives us 30. Okay, so simplify to see. We're going to get 50 minus 20 is equal to 30, which tells us 30 equals 30. So we get a true statement. Okay, so again, it works in the first, but we need to check out the second equation as well. It's got to work for both. All right, so let's move over here. Let's look at the second equation. So 2x plus y is equal to 10. Okay, again, I'm going to plug in positive 10 for x and a negative 10 for y. I'm going to get 20 plus a negative 10 is just the same thing as minus 10. Okay, so we're going to end up with 10 minus 10. Oops, I wrote the wrong thing. We're going to get 20 minus 10. What am I doing here? We're going to get, okay, back up. All right, so we have 20 minus 10 is equal to 10. Left side is 10, so 10 equals 10. This is a true statement, okay? So we took this variable assignment, okay? We plugged it into both equations, and we got true statements both times, okay? So this variable assignment is a solution to this system of equations, okay? So I'll write right here, this is a solution to the system in part B. Okay. All right. We are going to talk now. We're going to move into the methods that you can use to actually come up with the solutions to systems like this. Okay. So let's start. We're going to start with the graphical method.